Hello everyone. Today we are going to start integration. And also we will discuss how we use integration in kinematics, that is motion along straight line and motion along plane or two dimension. So in physics, we know that one quantity changes with some other quantity. Like for example, position changes with time, velocity changes with time, acceleration changes with time. Sometimes we have a relation between acceleration and velocity. Sometimes we have relation between velocity and position. So basically, we have xt relation, vet relation, at relation, vx relation, ax relation, av relation. So we can have any relation among these. So how integration is involved in solving questions related to these relations. So first we will discuss the meaning of integration. Integration means sum. We all know what is a sum. Like for example, if I say 2 plus 1, so we know it is a sum of two numbers, 2 and 1, that is equal to 3. What if I say that this 2 is change in quantity and 1 is also change in quantity? For example, let's suppose 2 second plus 1 second is equal to 3 second. So that means the time duration, this is the first time duration, we can call it delta t1, and this is the second time duration, we can call it delta t2, and this is 3 second means it is delta t1 plus delta t2. So we are adding the first time duration and next time duration, and we are getting the total time duration. Similarly, suppose I am saying 1 meter plus 2 meter. So this 1 meter can be first displacement, 2 meter can be next or second displacement, next or second displacement. So we can call it change in position. So this is first change in position, and this is next change in position or second change in position, next change in position. So we have change in quantity. So suppose something is changing in physics, we have so many examples of change. Time is changing, time is always increasing. In motion along a straight line, x quantity x is continuously changing. So suppose first displacement is 1 meter, next displacement is 2 meter. So what is total displacement? 1 plus 2. So first change, next change. So we are adding changes. We are adding changes. Similarly, it can be about mass. For example, you are putting some uh, substance in a container. You are dropping a small amount of some any substance in a container. For example, it can be a rice. Suppose 1 gram rice you are putting. After some time, you are putting 2 gram of rice, then 4 gram of rice, like that. So the mass is changing. So what is the change in mass? First time it is 1 gram, next time it is 2 gram. Next time it can be 3 gram, it can be 4 gram. So total change in mass will be 1 plus 2 plus 3 like that and so on. So when we add changes, that process is known as integration. Now in physics, change is denoted in two ways. When we say delta x, this is known as total change. It can be written as final value minus initial value, x final minus x initial. Similarly, when we are saying delta v, it will be final velocity minus initial velocity. So that is change in velocity, change in velocity. So concept is same. That's why we are taking example of position and velocity. Position can be changed, velocity can be changed. So delta x, delta v. Then what is dx? Dx is very small change. It is so small, but not zero. It is very small change, but not zero. Similarly, dt is very small change in time, but not zero. Very small change in time, but not zero. So this is also known as instant. This is also known as instant of time. So what do you mean by instant of time? Let's take one example. If you throw some object vertically upward, thus the object will go up, it will come to the topmost point, then it will come back, it will come down, start coming down. If I ask how much time it spent at the topmost point, suppose let's take example, it is taking 2 seconds to reach the topmost point, then it will take another 2 seconds to come down if we ignore air resistance. So how much time it is spent at the topmost point? So answer is not zero. Answer is instant. That time duration is known as instant of time, which is not zero, but it is very small. So it is denoted by dt. So when you add all the instants of time, that is small changes in time, that means dt plus dt plus dt plus dt plus dt plus dt, like that you keep on adding all those small instants, we get delta t. That is known as total change in time. So suppose dt plus dt plus dt plus dt plus and so on, then we can call it delta t. Small changes in time we are adding and we are getting total change in time. So this process is known as integration. So integration we don't use in our daily life. We can use some addition in our daily life. Integration is specifically used in physics when you are adding small changes mathematically. How do you add mathematically? So we have a process that is known as integration. Let's take one example. Dx by dt is equal to v. We know this already. V is the instantaneous velocity. Instantaneous velocity. So dx is a very small displacement. Very small displacement, and dt is very small time duration, very small time duration. It is so small but not zero. dt is a small time but not zero, dx is a small displacement but not zero. That is known as instantaneous velocity. So we have dx is equal to v dt. It is just a simple rearrangement. So a small displacement dx can be written as instantaneous velocity into small time dt. So for example, along this straight line, the particle is moving. Let's consider here to here. Let's consider this point is A, this point is B. A to B, the small displacement is dx. And how much time it took to finish this dx is dt. So dx is covered in time dt. So what is the velocity? So we know that velocity is instantaneous velocity is dx by dt, so that is displacement by time. So the displacement is covered in very less time and the time is very less dt. So dx by dt is instantaneous velocity. So when we multiply instantaneous velocity with dt, we get dx. So what about next dt? Suppose in next dt, it is coming to point C in next dt. And the displacement covered is also dx, or it can be some other value depending on velocity. If in next instant the velocity is more, so it will cover more displacement. We can call it dx again, but this dx and this dx can be different because we know that dx is equal to v dt. So dt is same. A to B time dt is same as B to C. So dt is same for A to B and B to C. The time duration is same, that is the instant of time is same. Time taken from A to B is same as time taken from B to C. But the velocity, instantaneous velocity can be different. Maybe it is 1 meter per second from A to B. Maybe it is 1.1 meter per second from B to C. Or maybe it is 0.99 meter per second from B to C. So next dx can be more than previous dx, can be less than previous dx. If velocity is constant, that is uniform motion, then this dx and this dx will be equal. So depending on this value of instant velocity, this dx may be same or it can be different. So, but our work is to find total displacement. So the meaning of finding total displacement is you have to add all these dx. These dx can be positive, can be negative also. Suppose the velocity is left side, so the dx will be negative. So mathematically, how to represent the sum of all the dx? It is denoted like integration of dx. So when we write this type of symbol, it is known as sign of integration. Sign of integration. So, and how, what we call this? We call this integration of dx. Integration of dx means we are adding all the small displacements. Those displacement can be positive, can be negative. So on the right side, what we will get, we will just substitute dx as v dt. So integration of dx will be called as integration of v dt. But how to solve now? What is next after this? it is fine that integration of dx means we are finding small changes in position. That means small displacements, and that will be equal to total displacement. That also we know that this is total displacement. So I can write it as delta x. So this is total displacement. But what is this? How to calculate this? Here comes the formula. So what is the formula to calculate this? The integration of v dt depends on what is v. V is constant or variable. Variable means function of time. If v is constant, then we call it uniform motion. Uniform motion. If v is variable, then we say it is non-uniform motion. So one by one we will discuss, because integration is very important topic in whole physics. So let's discuss one by one. What if v is constant? Let's discuss this first. Suppose this is a straight line. Let us suppose a car is moving along this straight line with constant velocity. Let us suppose the constant velocity is 2 meter per second. Suppose the point A and point B, the car is going from A to B and the time taken is dt. So the displacement dx will be v dt, and v is constant 2 meter per second, so it will be 2 dt. In next dt, it will go from B to C. Velocity is constant, so in next dt it will cover the same displacement v dt, and v is same as 2, so 2 dt. Similarly, suppose there is a point D, C to D. In next dt, it will cover the same displacement dx, which is equal to 2 dt again, and it will go on like this, because velocity is constant. Velocity is constant. So all the displacements dx, 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 next dx, all will be equal, because velocity is constant. So how to write that displacement? So delta x will be equal to 2 dt plus 2 dt plus 2 dt plus and so on, and we will take 2 common. It will become dt plus dt plus dt and so on, and this will be equal to 2 times of integration of dt. Integration of dt means you are adding all the small changes in time. So integration of dt, and we know that when you add all the small changes in time, we get delta t, total change in time. So that is 2 times of delta t. So how to write this delta t in some other way? So integration of dx can be written as delta x, integration of dt can be written as delta t, and delta x can be written as x final minus x initial, and x final minus x initial can be written as x with limits x initial to x final. So when we have integration of dx, it can be called as x, and we will put one vertical line like this, and we'll write initial value here and here final value. So these are known as limits of integration. This is known as lower limit, and this is known as upper limit. Lower limit and upper limit. So it will be called as x final minus x initial. Means you are substituting x final here, x instead of x you are putting x final, then you are writing minus sign, then you are putting x initial here like this. Next, what if the velocity is not constant? So basically this is the constant velocity. So we can say if velocity is equal to constant, and suppose the constant velocity is v naught, so the total displacement will be given as integration of dx with initial value x initial to final value x final, and that is equal to integration of v dt, and v is v naught, so integration of v naught dt. So this is v naught outside, integration of dt, and this integration of dt will be a t with limit t1 to t2. So this will be v naught into t2 minus t1, t2 minus t1, upper limit minus lower limit. So we have delta x is equal to v naught into delta t. So this is how we solve when velocity is constant. Let's take velocity variable. Variable means it will depend on time. Suppose v is equal to t. So that means at t is equal to 0, velocity is 0. After some time, let's take 1 second, velocity will be 1 meter per second. At 2 second, velocity will be 2 meter per second. So velocity is not constant, it is changing. The particle is speeding up. Particle, it is speeding up. Speeding up. It is going more and more fast. Initially, it is slow. Then the speed is increasing. So it is going more fast. How to find displacement in this case? So dx will be equal to v dt. So v means t here, t dt. So now the dx depends on time t. Which instant we are talking about? Which instant we are talking about? So for this type of expression t dt, we have a formula. Integration of t power n dt is equal to t raised to n plus 1 by n plus 1. So for this we will write dx is equal to t raised to 1 plus 1 by 1 plus 1. Integration of dx will be t raised to 1 plus 1 by 1 plus 1, and this is t square by 2. Then we will put the limit t1 to t2. Initial value of time is t1, final value of time is t2. So we have delta x is equal to t2 square minus t1 square divided by 2. So this is how we calculate displacement. If velocity is not constant, it is t. So suppose velocity is equal to t raised to n. So how to find displacement? It will be integration of dx, and we know that dx is equal to v dt. So that will be integration of v dt, integration of t raised to n dt, and formula for this is t raised to n plus n, t raised to n plus 1 by n plus 1, and limits will put t1 to t2. So it will be t2 raised to n plus 1 by n plus 1 minus t1 raised to n plus 1 by n plus 1. We will apply this type of formula. So suppose we have v is equal to t cube, and we have to find total displacement from t is equal to 0 to t is equal to, let's suppose, 2 seconds. So total displacement is equal to delta x, which is integration of dx, which is integration of v dt, which is integration of t cube dt. So that will be equal to t raised to 3 plus 1 by 3 plus 1, which is t raised to 4 by 4. Now we will substitute the limits of time, which is t is equal to 0 to t is equal to 2. So we have delta x is equal to 2 raised to 4 by 4 minus 0 raised to 4 by 4. So that is 16 minus 0 by 4. So that is equal to 16 by 4, which is 4 meter. Let's take one more example. Suppose v is given as t square plus t, and question is find displacement in find displacement from t is equal to 2 second to 4 second. So time duration can be from 0 to 2, 0 to 1, 1 to 2, 2 to 3, 2 to 4. Initial and final value can be any value of time. We just have to take care the limits here. Suppose t is equal to 2 second to 4 second they are asking. So that means the initial limit is 2 second, and final limit is 4 second. So we will find the displacement, integration of dx, we can call it delta x also, or we can call it s, which is the symbol for displacement. It will be integration of t square plus t dt, because we know that dx is equal to v dt. So that is equal to integration of t square dt plus integration of t dt. This is known as sum rule. This is sum rule in integration. Now we will use the formula t raised to n dt means t raised to n plus 1 by n plus 1. So this will become t raised to 2. So t raised to 2 plus 1 by 2 plus 1 plus t dt will become, now t dt means the power of time here is 1. So it will become t raised to 1 plus 1 by 1 plus 1. So this will become t cube by 3 plus t square by 2. This is the integration. Now we will substitute the limits. So here only we can write the lower limit is 2, upper limit is 4. This is also known as lower limit, and this is upper limit or final limit. So we will write like this, 2 to 4. Now you will substitute 4 in place of t here. So it will become 4 cube by 3 plus 4 square by 2. Then you put minus sign. Now you substitute 2 in place of t in this expression. So 2 cube by 3 plus 2 square by 2. So this is now 4 cube will be 4 into 4, which is 16 into 4. So 64. 64 by 3 plus 4 into 4, 16 by 2. Then it is just we have to solve this. So this is 8 by 3 plus 4 by 2. Then we can solve this, and that will be our answer for displacement. So I am keeping the final answer up to you. You can find the final answer. Next, let's take example from fractional power. Suppose we have V is equal to square root of t, and the question is find displacement in first 4 seconds. So the same formula we will use. It will be equal to integration of dx, which is integration of v dt, which is integration of root t dt, because v is given as root t. So that is t raised to 1 by 2 dt. Now t raised to 1 by 2 dt will become t raised to 3 by 2 divided by 3 by 2, because 1 by 2 plus 1 is 3 by 2. So we have delta x is equal to t raised to 3 by 2 into 2 by 3, and t raised to 3 by 2 can be written as t square root of t. Now substitute the lower limit, which is 0. First 4 second means 0 to 4 second. So initial is 0, final is 4. It will become 2 by 3 into 4 root 4 minus 2 by 3 into 0 root 0. So basically this whole number will be 0. So 2 by 3 into 4 root 4, which is 4 into 2. So 8 into 2 by 3. So 16 by 3 meter. Let's take one more example in which the power is negative. Suppose V is given as 1 by root t, and the question is find displacement from 4 second to 9 second. So intentionally I have given the values as 4 and 9 so that we can find the square root easily. So dx, integration of dx will be delta x, which is integration of 1 by root t dt. So 1 by root t can be written as t raised to minus 1 by 2. So that is t raised to minus 1 by 2 plus 1 by minus 1 by 2 plus 1. So this will become t raised to 1 by 2 divided by 1 by 2. So this is 2 t raised to 1 by 2, or 2 square root of t. Now we will substitute the limits, which is 4 to 9. So we have delta x is equal to 2 square root of 9 minus 2 square root of 4. So 2 into 3 minus 2 into 2. So that is 6 minus 4. So answer is 2 meter. So this is the integration basics. Now we will apply this in more examples of physics, that is motion along straight line. Now we know that dx by dt is equal to v. So dx is equal to v dt. We also know that dv by dt is equal to acceleration. So dv is equal to a dt. Can we solve one question in which acceleration, velocity, and displacement, all three quantities are involved? Let's try. Suppose the acceleration is given as 2t. So this acceleration depends on time t. It is not constant. It is a non-uniform acceleration. Non-uniform acceleration means the acceleration is not constant. In this question, acceleration is not constant. So we will write uh, dv by dt is equal to 2t. But before that, let's complete the question. Question says initial position. Initial position means when time is 0. When time is 0, initial position is x is equal to 0, and initially particle is at rest. Initially particle is at rest, or we can say the particle start from rest. So t is equal to 0, the velocity is 0. This is the information given in question. So we have to be careful about this type of information. This is important information. The question is full of information. So we have to read line by line what information is given in question. Find displacement in first 2 seconds. That is the question here. Find displacement in first 2 seconds. First 2 seconds means t is equal to 0 to t is equal to 2 seconds. 0 to 2 seconds. Now in this question, acceleration is involved, but the question is displacement. So directly we cannot find, we have to find velocity first. So we will start with, we can call it step number 1. So acceleration we will write as dv by dt. So dv is equal to a dt. So this is instantaneous acceleration, instantaneous acceleration. So now our next step is to find instantaneous velocity and then instantaneous position. So dv is equal to a dt. So we will integrate on both sides from initial time 0 to final time t. Now t is any time. It can be 1 second, 2 second, 3 second. It is a general instant time t. Now when time is 0, the velocity is 0, and at time t the velocity is v. So the integration of dv will be v, and limits will put 0 to v, and on right side we will put a dt. Now we have a is equal to 2t. So 2t integration, and time is from 0 to t. Now integration of 2t will be 2 into t square by 2, which is t square. Now limits of time is 0 to t. So this will be t square minus 0 square. So basically it is t square. On the left hand side, we are getting v minus 0, so that is equal to t square. So v is equal to t square. So this is known as instantaneous velocity. If you put time value in this, we'll get corresponding velocity value. Suppose at 2 second, what is velocity? It is 4 meter per second. At 3 second, what is velocity? It is 9 meter per second. Now we will write v is equal to dx by dt. So dx is equal to v dt. Now substitute v as t square here. So dx is equal to t square dt. Now integrate on both sides. So integration of dx is integration of t square dt. So integration of dx is x. Now limits also we have to think. So let's go back to question. In question they are asking displacement in first 2 seconds, means the limits of time is 0 to 2. So lower limit of time is 0, upper limit is 2. So we will integrate it from 0 to 2 seconds, and the displacement will be from 0 to final x. So we can call it delta x, total displacement in 0 to 2 seconds, and it is starting from origin. It is given in question. So the lower limit of position is 0 according to question, and this will be t cube by 3, limits 0 to 2. So the 2 cube by 3 minus 0 cube by 3, so that is 8 by 3. So displacement is 8 by 3 meter. That is our final answer. Let's solve one question in which the information given will be different. Suppose a is equal to, let's suppose it is t plus 1, and initially means time is 0. When time is 0, particle is at x is equal to minus 2 meter, and its velocity is 1 meter per second. Now this is the information. We have to read this very carefully, because in integration we have to consider limits, lower limit and upper limit. So how to start this question? Okay, the question is same. Find displacement and final position. Find displacement and final position after 2 seconds. So the limit of time is 0 to 2 seconds. Initial time is 0 second, final time is 2 second. So between 0 to 2 second, what is the displacement? That is the question. And also, what is the final position? Because initial position is given as minus 2. So in the question they are asking what is the final position. So two answers you have to give, because there are two questions, displacement and final position. So we will start with dv by dt. Dv by dt is equal to t plus 1. So dv is equal to t plus 1 dt. So dv is equal to t dt plus 1 dt. Now integrate on both sides. Specifically, you have to consider limit. When time is 0, the velocity is not 0 here. You have to read the question carefully. When time is 0, the velocity is 1. When time is t, the velocity is v. So integration of dv is v, limits 1 to v. Initial value of velocity is 1 meter per second, and the final value is v meter per second. So we can write 1 to v. Then right side it will be t dt integration. So it will be t square by 2, 0 to t, plus 1 dt integration will be t. Integration 0 to t. So now we have, now in v is there, lower limit 1, upper limit v, so it will be v minus 1 is equal to t square by 2 minus 0 square by 2, and then plus t minus 0, so it is t square by 2 plus t. So we have v is equal to t square by 2 plus t plus 1. So carefully we have to consider the lower limits. If the question says the particle start from rest, so the initial velocity is 0, the lower limit will be 0. And just imagine if the lower limit is 0, you will get 0 here. So your answer will be v is equal to t square by 2 plus t. So this 1 will not be there. But in this question, the initial velocity is 1 meter per second. At time 0, velocity is 1 meter per second. So here you are seeing v minus 1. So when you find v, you will have plus 1 here. So this is instantaneous velocity. Instantaneous velocity. Now we will continue our solution. Find displacement and final position after 2 seconds. So we will write v is equal to dx by dt. So we have dx is equal to v dt, which is t square by 2 plus t plus 1 dt. So now we will integrate on both sides. So integration of dx is equal to integration of t square by 2 dt plus integration of t dt plus integration of 1 dt. Now again we have to put the lower limits. When time is 0, the position x is not 0. Let's go back to question. What is the initial position given in question? Initial position is given as minus 2. Initially means when time is 0, the position is minus 2. So when time is 0, position is minus 2. And when time is t, the position is x. So this is the final position. And we will put t is equal to 2, because in the question they are asking what is the position at 2 seconds. So first we will find position at any time t, then we will put time t is equal to 2. Integration of dx is x, limits minus 2 to final position x. Then right hand side it will be t cube by 3 whole divided by 2 plus t square by 2 plus t. Then this is t cube by 6 plus t square by 2 plus t, and then we will put the limits, which is 0 to t. Left hand side we are getting x, upper limit is x minus, lower limit is minus 2. So this will be x minus minus plus, so x plus 2 is equal to this will be, when you put a t, it will be t cube by 6 plus t square by 2 plus t, and when you put 0, this whole term will be 0. So we have x is equal to t cube by 6 plus t square by 2 plus t minus 2. This is the position x at any time t. So this is instantaneous position. Instantaneous position. You put any value of time in this expression, you get corresponding value of position. So in the question they are asking, find final position at 2 seconds. So just substitute here. So final position will get, put t is equal to 2 here. So 2 cube by 6 plus 2 square by 2 plus 2 minus 2 So that is 8 by 6 plus 4 by 2 plus 0. So that is 4 by 3 plus 2. So that is 4 plus 6 by 3, 10 by 3 meter. This is the final position. So what is the displacement? So displacement in 0 to 2 seconds, 0 to 2 seconds, so delta x will be final position minus initial position. Final position is 10 by 3 minus initial position is minus 2. So that is 10 by 3 plus 2. So that is 16 by 3 meter. So displacement is 16 by 3 meter. Final position is 10 by 3 meter.